Good morning, everyone, and welcome to today's webinar, QIF 3.0 Applications by Tom Kramer. Before we get started, we're going to have some housekeeping. Tom, would you click the slide? Thank you. So today you'll be in listen-only mode, but you will be able to ask questions. If you look on the control bar on the right-hand side, there is a section of questions. You can ask a question, and during the presentation at the end, we will be going through a Q&A section. So please ask your questions. We'll have a panel of people looking at them and getting them organized for today's discussion. Just a reminder that we will also be sending you an email with a link to today's presentation and to the recording of this presentation. Next slide. So today's speaker is Tom Kramer. He's a NIST guest researcher, research associate at Catholic University, and a QIF developer and software developer in general. We're going to take a few seconds here. We're still getting a few more people, so I'm just going to pause for a few seconds here, and then we'll start the presentation. So Tom, why don't you get started?
All right. Good morning, everybody. Thanks for joining. I'm Tom Kramer. I've been a guest researcher at NIST since 1984. I've been working with the DMSC for 25 years, and I've been helping develop QIF since 2011. I want to first thank my colleague, Bob Stone. He's a DMSC member and a software developer. Much of the software I'm talking about today was built by Bob. And he's also my alter ego in the sense that he and I always think alike. We're able to complete each other's questions. So Bob made a good video, and here's a link to it. It covers roughly the same material as we're talking about today. A quick rundown of the DMSC. It's the Digital Metrology Standards Consortium, a nonprofit consortium organization. It's been a separate legal entity for about 15 years now, dedicated to encouraging the development and interoperability of information standards that benefit digital metrology. It prepares standards that impact digital model-based quality. And it's a professional group of technologists, developers, and innovators. The DMSC maintains the Dimensional Measuring Interface Standard and has recently built the QIF standard. It's an ANSI-accredited standards-making organization, so the QIF standard is an ANSI standard as well as a DMSC standard. And it's an A liaison member to ISO. And QIF has recently become, or is almost finished becoming, an ISO standard. So what is QIF 3.0 from a software developer's perspective? So I'm mainly talking to people who are interested in building programs that deal with QIF. QIF 3.0 is a standard. You can download it for free. It's heavily documented. It won't change. There may be eventually QIF 3.1 or 4.0, but 3.0 will still be 3.0. Scope is quality. It's kind of based in dimensional metrology, but it's broader than that. And it includes results, statistics, measurement resources, measurement plans, rules for how you go about doing inspections, model-based definition, and visualization. Formally, it's a data model defined in XML schema definition language. The data files are governed by the model. The model is an XML schema definition language model, but in addition to the model, there are XSLT constraints that are also normative. If you want to have a valid QIF data file and you want to figure out whether it's completely valid, you would check it first against an XSDL checker, such as XML Spy or Oxygen, and I'm sure there are several others. And then you would also check it against the XSLT constraints that are included in the standard. And one thing about it is that it's big. There are a couple of senses in which it's big. If you attempt to load it into a typical model checker, such as XML Spy or Oxygen, and you turn on constraint checking, neither of those systems will be able to handle it. You have to turn constraint checking off. The kind of constraint checking that's built into the XSLT is keys and key refs. If you generate code from QIF3, and we'll be talking about code generators in a minute, you'll get about close to 40 megabytes of code. So that's another sense in which it's big. Let me just briefly say what the most typical workflow is with QIF. The first item is this QIF MBD, model-based definition. And you can feed into that from commercial CAD systems. Once you've got the data into a QIF MBD, you can make plans. You can actually make plans without QIF MBD, but it's going to be a heck of a lot easier if you use it. And the kinds of plans you can build vary all the way from simply saying, what do you want to measure, to a great deal of detail of not only what you want to measure, but also how you plan to measure it. And the how can include QIF resources. This is information about resources like CMMs, calipers, theodolites, micrometers, etc. And you can use rules for governing how you make plans. QIF provides a format in which you can define rules. QIF does not specify what the rules are. It only provides you with a way to write down the rules that you want to write down. So once you've got really your plan in place, you might execute that plan by writing for example, a CMM program, which could be written in DMIS. That's the DMSC CMM programming language. And DMIS is fully linked into QIF. It was modified specifically to work with QIF a couple of years ago. Once you run your program, you get results, and you can save those in QIF results. And if you want to, you can do statistics on the results. So that's the typical workflow. You don't have to follow that workflow. You could have for example, a QIF rules file with nothing but rules in it. And if you are making rules, that's probably what you would do. Any QIF file is a QIF document file, but the QIF document has relatively few required things. So let's go on. So how does the software developer support QIF? Supporting QIF means that the software that you write or build will read or write QIF documents in XML format. The XML format is the format for data that conforms to the QIF model. And once you've got your data or rules or whatever in an XML format file, you should check to make sure it's valid against the model, which is in the schema files, and also that it meets the constraints of the XSLT. So how do you get started? Step one, download the standard. It's free, it's easy to download. And when you do that download, you get not only the model files, which are the XML schema files, you also get a big text document and a number of sample XML instance files. If you're programming QIF, you'll find it very helpful to study instance files. Study the text doc. I would suggest going pretty quickly to the overview section of the text doc, but you really need to read that first to get a general idea of what QIF is all about. And then there is HTML documentation at this location. And I'm going to just skip there briefly. So this is where you get started if you want to learn about QIF online. Here's the URL. And notice that it's got source code bindings, instance files, and the schema browser. So let's briefly go to the schema browser. Here's the schema browser. Now, the best place to get started is with QIF document. You got to scroll down through this great big list to find it. It's in between P and R. So there's QIF document. So this is a model of the QIF document. Well, it's called a type, but conceptually it's a class. I'm not going to go through this, but if you go there, suppose you want to look at datum definitions, you just click on that, goes to datum definitions, and you can navigate back and forth using the arrow keys. So let me just leave it at that. I'll leave it to you to use that. So Ray, do you want to run a poll?
Yes, and the first poll question is, do you plan on building your own code to read and or write QIF? Please select yes or no. And the polls are open, so we'll let you vote here, and in a few minutes we'll check in, see what the results are.
While you're doing that, here's how you get started. Am I audible, Ray?
You're audible, no visual. So give you a moment more here. We have about 70% in. Okay, I'm closing the poll. We're at 75. And let me. Here. So there's the results. We have about 62% that are going to build their own code and 38% that are not going to be building their own code. It's back to you, Tom.
All righty. To get started, the first step is to download the standard. Study the text doc. Study the HTML. We've already mentioned those items. Then pick an approach to dealing with QIF. You could simply print directly.
Tom, do you want full screen?
Yeah. Do I need to click something?
Just put PowerPoint back in a full presentation mode.
Oh, I'm sorry. Yeah, sure. So pick your approach to dealing with QIF. You can either write a program that prints directly using whatever code you like. You might be able to use XPath. You might be able to build a document object model. Or you might start with existing source code bindings. And that's what we'll be talking about today, is using source code bindings. So where do you find source code binding generators? Well, take a look at the internet. Wikipedia lists a number of source code generators. And you can easily find at least these three. One is C++, which is code synthesis. One is Visual C#, and one is Python. So you could pick any of those, and the webinar today is going to show you how these sample files use each of these three code generated by each of these three generators. But there is also available a collection of items that includes source code bindings. You don't need to generate your own, but this is only in C++. What it includes is C++ classes for all of QIF, except that the signature class is modeled as a string. And in addition, there is a whole collection of model-independent classes that give you classes to manipulate primitive data. The YAC-LEX parser is included. And what it does is it will read an instance file and build an abstract syntax tree in terms of the C++ classes. The C++ classes all know how to write themselves, so you can write out an abstract syntax tree to an instance file. And there's a minimal application that simply reads a file in and writes it out. You can use that to check that your file is valid. And then there's a makefile. Now, the makefile is only good for Linux-like systems. If you're programming in Microsoft Visual C++, you'll need to build your own builder. But be careful here. All the software is provided as is without any warranty. Read the DMSC license. The DMSC doesn't provide the code generators or the code generated by them. And if you use code generated by one of the commercial source code generators, you have to comport with their license. And so, Ray, did you want to run the second poll?
Yes. So if you will be doing coding, what language will you be using? C++, C#, and or other .NET languages, or others? So the voting's open. We'll give you a few moments to vote now. All right, we have about 60% in. I will give you another few moments to get your vote in, and then we'll see what the results are. All right, the voting is closed. The results are C++ 18%, C# and .NET languages 35%, Python 38%, and others 9%. Back to you, Tom.
All righty. Oh, and finally, the DMSC does not endorse or recommend any particular source code generator. So what do source code binding generators do? They're all good at automatically creating classes from schema files. So you might see this in the schema definition. And here's the sort of source code that might be generated. In XML schema definition language, things that you would normally call classes are defined as types, either simple types or complex types. But they both translate into classes. What the binding generators don't do well is to implement constraints. So there are hundreds of keyref constraints in QIF 3.0, but no code generator will write code that will perform those checks. So be aware of that. And they also don't have anything to do with the XSLT constraints. So let's talk a bit about the free open source apps from DMSC that you can download. Three of the apps use code that you generate using a code generator. All three of these apps produce the same QIF instance file. There are really two parts to each of these three apps. The first part is to build an instance file and run it. Excuse me, build code that writes an instance file and run that code. But they also include a more or less separate app that reads the instance file and produces DMS for actually doing an inspection. And they all run in Windows. The fourth app, which I wrote, the first three apps were written by Bob Stone. I wrote the fourth app, and it uses the binding code that's in the QIF community site. So you can use that. Builds the same instance file as the other three instance file builders. It doesn't produce any DMS. It's not linked to any particular operating system. And there are two versions that demonstrate different coding approaches. One key thing about the source code that you can download is that in all cases, objects are connected by pointers. And there are two ways that you can do pointers if you're doing C++. You can either use new to create something, or you can use automatic variables. So in the case of new, you always get a pointer. For automatic variables, when you link things, you have to create a pointer. And here's another indication of where you can find the apps. If you go to the site that we went to before, you can go directly to the apps. So if you want to go to the apps, here they are. Okay. So what do the apps do? Well, all of them encode this drawing, really. This drawing has 4 features on it, although apparently we've only used 3 of them in the sample code. It's got datum reference frames, 3 datum reference frames. It's got various kinds of tolerances, flatness, perpendicularity, position. And the code actually writes a QIF instance file that looks like this. In order, if you go through the code, you'll find that it sets up units, it defines datums, defines datum reference frames, defines features. Now for features, you need 3 aspects called definitions, nominal, and item. Read the text file to figure out what the heck that's about. You have to hook your features to datums. And characteristics also have definition, nominal, and item. You might want to define measurement resources, and the sample code files do define measurement resources. The code files include a trivial measurement plan, and they all generate a valid QIF document. So here's some sort of typical code from one of Bob's programs. And if you want to use one of these programs as a template, you can. All you need to do is copy this kind of code and put in your own data. So that's what the instance file writing programs do. That's the output side. On the input side, the apps read that instance file that was just written, and they write DMS. So here's the DMS that they write. So in a little bit more detail, the input code extracts stuff such as units from the QIF instance file and puts it into the DMS file. And it does similar things with features. There's features in QIF, features in DMS, feature nominals. That's the definition of the feature before you measure it. Characteristic nominals. And then feature actuals, that's after you've measured it. And actual characteristics, which are called tolerances in DMS. And it does datum definitions, and it generates an entire DMS results document. And then it views the output in Notepad. So here are some videos that Bob built showing what you will see if you build these things yourself. First, it's going to write the QIF instance file. You have to give it the name of what to write. Here's what it wrote. So this is the entire actual instance file that gets generated. Then the second app reads that file, and it'll write the DMS output file. And there's the DMS output file. Now the Visual C++ does pretty much the same thing. So I'm going to skip through this. The Python is a little bit different. It pops up a command window. But again, you tell it what you want it to write. It writes that. It's the same instance file as before. And here's the other app that's part of that writes DMS. Again, you tell it what to read, you tell it what to write. And it writes that. Okay, Ray, did you want to do the last poll?
Yes. And our last poll is, if you will be building code to handle QIF, how will you build it? QIF source code bindings from QIF GitHub site C++ or C#. I will use code generator to generate source code bindings. I will build my own source code bindings. Another approach that does not involve source code bindings. So the open for voting now. And while you're voting, just a reminder that you can ask questions in the question box on the right-hand side on the go to webinar sessions. So feel free at the end of the seminar, we'll go through a Q&A session. So please feel free to add that too. Okay, we have about 50% voted. I'm going to give it another moment and then we'll close the voting. And I'm going to close. And as you can see, 54% are using the C++ or C#. 29% will use the code generator, and 13% will build their own source code bindings, and 5% with another approach. Thank you. Tom?
Okay, if you are using the C++ source code that is provided by DMSC, download the code, read our license agreement, read the README, which explains how to build things. Build the executable that reads an input file and writes an output file. That's the executable you can use to check your own QIF instance files. Then you might want to build and run the two apps that both generate a tree and write an output file. Now, if you're using a code generator, there are more steps to go through. You still need the schema files. You actually don't need the schema files if you're using the code provided by the DMSC. If you're using a generator, you have to download the schema file, download one of the applications, read our license agreement, follow the instructions in the README, download the source code generator from a source that you select, read their license agreement. Now, if you do use one of the source code generators, you're likely to find some difficulties. You may find some things that the source code generators have trouble handling. So you may need to edit the schema file somewhat. Then generate the source code bindings, and you may need to modify the source code bindings somewhat. And then build and run the application. Here's what the source code looks like in 3 different languages. It's annotated, that is, it explains what it's doing. All 4 applications have parallel implementations. That is, if you compare the code, you'll see that they're all in pretty much the same order. They're able to deal with lists, they're able to check for lists, traverse lists, handle substitute elements, and for the 3 apps that Bob did, the code is regionalized. So if you use that code, it'll get you past difficulties that you wouldn't have known existed. Don't need to go into detail on those, but you may run into these difficulties if you do your own source code generation using one of the source code generators. So what are the takeaways from today? One, we wish you good luck in implementing QIF3. Free open source C++ code is available for QIF 3.0. QIF works with source code binding generators that eat XML schema definition language. There are a number of open source apps you can examine build and run to help you understand how to go about building your own code. You can use them as templates. If you run into problems, you can enter an issue on the QIF community on GitHub. And finally, we'd like you to contribute. How can you contribute? You can write an application in a different language, such as Visual Basic or Java. You can use a different OS. And I should mention here that this is Bob Stone's slide, and I became a contributor after Bob built this slide. So I use Linux. You could use a different compiler. I used a different compiler. I used the GNU compiler. You can use a different source code generator. They are out there. And share your code, but don't share automatically generated source code. With that, I'll throw it open to questions. And thank you for your attention.
Thank you, Tom. I'd like to also introduce that we have some panelists on, Curtis Brown, Bob Stone, and Daniel Campbell, and we'll be asking questions. And if you stump you, Tom, we have a few others to back you up. Daniel, would you like to ask the first question?
Yeah, so we've collected some questions from the audience, so we'll just start to go through them. I guess one question here is, any thoughts on the ability to support JSON?
I have not seen people using JSON with QIF 3.0, but actually the only thing I'm paid to do these days is JavaScript development. So I use a lot of JSON. I would expect that JSON would be usable, but what it would look like, I don't know.
Okay, another question here is, so Tom, you had been talking about the key-ref checks. The question is, what are the implications of the lack of the possibility for the source code binding to make use of the key-ref checks?
Well, the key-ref checks make sure that what you're pointing at is the right class to point to. So without the key-ref checks being implemented, it's easier for you to make mistakes. And I think that's really the only limitation. It would be nice if the code helped you more than it's helping you. You can program your own key-ref checks.
So what would be an example of a key-ref check?
Well, for example, if you've got a circle feature nominal, it's supposed to be pointing at a circle feature definition. Now, the way that it points is it identifies the ID of the circle feature definition. If you put in as your pointer a pointer that points to the ID of something else, like a line, your code won't work. You will presumably attempt to ask the line what its diameter is.
Yeah. Okay. So let's move to another question then. Here's a question that's maybe along similar lines. How do you ensure that that independently written and generated QIF conforms to established QA standards? Is there a mechanism or a process currently in place that ensures quality and compliance?
We don't have any formal compliance checks at this point. The ways that are available. If you're using XML SPY, for example, you can load the schema files in, and then, well, actually, you don't need to load them in explicitly. If you load your instance file in, XML SPY will automatically load the model. And if there are errors against the model in XML SPY, they'll be flagged. XML SPY, for example, also lets you, it will report the key rough errors. So XML SPY will execute those constraints. XML SPY will also let you run the instance file against the XSLT. So using a tool like XML SPY, you can run all the checks that exist in QIF. I believe you can do the same thing in Oxygen, but I haven't tried it yet.
So I think the tools that QIF provides would be the schemas, and there are checkers out there that can ensure that the QIF files conform to the schemas. And then there are further checks implemented in the XSLT files, which are also part of the standard, that can also be run with common tools. Is that correct? Yeah. Okay. So here's an interesting question. Is it possible to set a particular way to evaluate a circle? Well, let's put it this way. Is it possible to code the way that a circle, for example, will be evaluated? In other words, like with a least squares fit, maximum inscribed, minimum circumscribed. And then furthermore, is it possible to define globally that, this is, generally speaking, how I would like to fit my circles?
Can I throw that to Bob?
Oh, yes. Well, on a per feature basis, you can define the substitute feature algorithm. And I'm just thinking, and it's not coming to me that there is a global default for that.
One way that could be done would be with rules. You could define rules that would state that, for so-and-so circles, I would like to use this type of algorithm.
That would do the job implicitly.
Let's see here. So here's a question. Does QIF work with step AP242 to extract GD&T info? And then I guess another question, are there any kind of persistent IDs for features? So maybe for the first question, does QIF, can it work with step 242?
There are efforts underway to harmonize STEP and AP242. They have a lot of similarities, particularly in the model-based definition area. There are commercial tools that will translate between AP242 and QIF for earlier versions of QIF. I think those will be available for QIF3 in the not too distant future.
Yeah, I mean, one other comment I guess I would have is that it is technically possible to have a QIF file that externally references another CAD file, which could even be a proprietary file like an X or CATIA file, but it could be a step 242 file or a JT file. And it could externally reference the geometry, and I think it can even externally reference the PMI in one of those files and build the QIF metadata based on that MBD core. So technically, I think that it is possible to have sort of a single data model that uses both. Tom, would you agree with that?
Yeah.
And to finish up the rest of that question, can you have a UUID on the feature? And the answer is yes. You can have a Cupid on a feature.
Yeah, QIF uses what we call Cupids, which are UUIDs by a different name. And every QIF document has to be uniquely identified by a QPID. But in addition, there are many places in QIF where you can use QPIDs and UUIDs to identify specific things like features and characteristics.
Okay. Let's see. How would you suggest approaching the idea of sort of hacking DMO or DMIS files into QIF results?
Bob?
Well, that's a good example of put your data here. You would parse the DMO file to extract XYZ IJK size information, and then put that into the data slots in your program. So you would, for instance, make a point type with the XYZ from the DMO and that sort of thing. So instead of the source being hard-coded as it was in the example files, they would be whatever variables you mapped the DMO parameters to.
Bob, while you are talking about this, it maybe for everybody out there who may not be so familiar with DMIS and with the relationship between DMIS and QIF, would you want to give a quick background on the relationship between DMIS and QIF?
Well, DMIS is a very old standard now. It's a text-based file that was based on app, the automatic programming text language. And so it's got a major word / minor word followed by parameters, which are things like cart, define Cartesian, XYZ, IJK, that sort of thing. And it's the dimensional measuring interface standard. So the idea was it was a neutral standard to go between native coordinate measuring machine languages. And over time, it was adopted by some coordinate measuring machine manufacturers as their native language. So it contains all the same sort of data as QIF, nominals, both location and size and orientation, actual information in the DMO, or I should say measured information. And so there's typically a one-to-one mapping between a parameter in DMIS and a data bucket in QIF. And that's the sort of manual process that is shown in the reading QIF and writing the DMO. So there would be sort of possibly a third sort of app that we could consider adding, which would be to read the DMO and populate the QIF as an illustration.
Great, thank you. Here's another question. Is the Python app written in Python 2 or 3?
That is a good question. The thing that we've noticed with the Python stuff, I think we would be free to hand out the source code bindings, but we don't because it's locked to a particular version of Pixby. And I believe the version we're running, or that a movie was done with, was 3.4.
Yeah, I think it's a 3 version.
Yeah, it's a 3 version.
Yeah. But yeah, the idea is that we give the instructions with this Pixby tool, which is a free tool that will generate Python for you. And it might actually depend what version of Python you have on your system and so forth.
Yeah, it depends both on the Python and the Pixby versions, the source code that is generated.
So at the end of the day, I think it's possible to generate to whatever version you want within reason.
Yeah, trust me, that was my first non-trivial Python app, so I didn't do anything fancy.
All right, so here's another question here. As a longtime coder with an impressive history of accomplishments at NIST, how would you attack the idea of putting your own data, aka putting your own app, into QIF from either the CAD perspective or from the DMSC perspective?
I'm not quite understanding the question.
Well, I guess what would be your preference in terms of, or the way that you would attack the problem if you wanted to write a QIF-based app, either from the CAD perspective or from the DMSC perspective? What would be some of the initial steps you'd take to attack that problem, and how would you approach that particular problem?
Well, Bob here. The first thing you would do is to map your data model to QIF. So whatever your boundary representation model inside CAD was, the parameters in DMSC, all those sort of things, you would decide which of your proprietary data or DMSC data maps to each QIF bucket, and then you make yourself a coffee and you have a lot of code to write.
Okay, panelists, we're coming up on the hour. We will address these questions that we didn't get to, and we will be sending that out. I want to thank Tom and the panelists for today's presentation of QIF 3.0 application guide. If you have any questions, you can reach us at info@QIFstandards.org. And when you leave today, we will be sending you an email with the presentation link and a link to the recording of this webinar. I hope everybody has a great day, and on behalf of the DMSC, I want to thank all of you for joining today. Thank you, and have a great day.